Hey all, hope you guys are well today. It is a Wednesday, kind of a little bit rainy, kind of a little bit dreary, so plenty of time to do what you need to do today. So today is kind of our last topic in this unit, and we are going to try to understand the idea of acceleration. We're also going to just kind of review a couple ideas here that we've covered, so we are ready for a test that's going to be coming up fairly soon. So, where have we been? What have we talked about so far this chapter? Okay, well, we've talked a lot about measurement because science is going to involve measurement, and we talked about the difference between precision and accuracy. For instance, you could describe my height as being 2.34 feet tall. That'd be precise but not accurate. You could say my height is 6 feet tall. That'd be accurate but not precise. But that's why we employ significant figures. Significant figures tell us how precisely we know a measurement. We also work with metric conversion because the language of science is going to involve the use of metric such as liters or grams or meters. And we also use dimensional analysis because we need to be able to convert between different types of units. So those are things dealing with measurement that we've talked about. But the reason we've been using measurement is because we've been trying to describe motion. And in doing so, we differentiated the difference between distance and displacement. They're going to seem kind of similar, but they're a little bit different. Displacement is going to include a direction. It's going to say how far you are away from your starting position at the end. So you could swim 50 meters in a pool, but only have a displacement of 0. Okay, it just kind of depends upon where you are. So that's the difference between distance and displacement. Now distance is going to give us a speed. Displacement is going to give us a velocity. A velocity is also going to include a direction. So those are some things that we're going to build upon today. So we need this basis down in order to talk about today's topic. Okay? And that topic is acceleration. So I want you to start taking some notes right here. That was just a little bit of a quick recap of where we are, just in case some of those ideas have gotten a little bit rusty. But make sure your notes are ready and pause the video when you need to in order to get down what you need, because you're going to be applying this stuff today. So what is acceleration? Here's our definition for acceleration. An acceleration is a change in velocity over time. Notice I'm not using the word speed. It's a change in velocity over time. Now, I could speed up, and that would be a change in speed, but velocity is a little bit broader term here, as we're going to see. So if I speed up, that's going to be an acceleration. If I slow down, that's going to be an acceleration. Okay, it's called a negative acceleration. It's called a deceleration. But finally, here's the kicker. If I change direction, I am also accelerating because velocity includes both speed and direction. So if I'm changing direction, I have to be accelerating in a different way. So that's going to be what is going to be important. As long as, if I'm going at a constant speed, as long as I'm changing direction, I am accelerating. Okay? So, we've been working a lot with graphs. And if I have a distance versus or displacement versus time graph or a velocity versus time graph, I can tell whether or not I'm accelerating. Okay? If I am speeding up, that's going to be a positive acceleration. I can tell this by the fact that my slope is increasing. Okay? What would a positive acceleration look like on a velocity versus time graph? That would look simply like so. Okay? This would be a greater acceleration. This would be a lower acceleration. What if I'm slowing down? Well, if I'm slowing down, now all of a sudden my curve, let's put this as a distance versus time, displacement versus time graph here. If I'm slowing down, now my graph is going to curve like this. That is a negative acceleration. That's a deceleration. And my velocity versus time graph, if my velocity is dropping over time, that's actually going to look something like so. That's a negative acceleration. So all of these graphs you should be able to interpret. We've worked through them in labs. We've done examples. So hopefully those are starting to sink in a little bit. But let's get to the nitty-gritty here. What does this look like in terms of solving a problem? So here's our basic equation. that you should be putting in your notes. Equation is going to be a change in velocity over time. We can shorthand that and simply say that acceleration, whoa, that's not going to help us. Acceleration is delta v over t. This delta is just kind of a Greek fancy way of saying that it's a change in velocity over time. So this is going to be a key equation for us to use. Now what's nice about this is, just like our last equation dealing with velocity, I can rearrange this and say that velocity then, my change in velocity, equals acceleration times time. So in this one I'm finding acceleration, this one I'm finding velocity, and I can also say my time it takes is going to equal my change in velocity divided by acceleration. So I kind of get three equations for the price of one. It just depends upon which of these I am looking for. Am I looking for velocity, acceleration, or time? And as long as I follow a certain method here, I'm going to be hunky-dory in terms of being able to solve it. So earlier in the velocity notes, we talked about how to calculate velocity. This triangle here might prove halfway successful for you. Okay? If you want to find acceleration, okay, whoops, I made this a little bit wrong here. This should be, no, this is right. So acceleration is going to be a change in velocity divided by time. So if I want to find this, I take velocity divided by time. If I want to find velocity, I take acceleration times time. If I want to find time, I take velocity divided by acceleration. This triangle will prove helpful for you as you try to solve these problems if you forget how to do them. Okay? So let's mosey on down the line here. Let's look at how you solve a sample problem. And these sample problems are actually on your assignment, so you can kind of watch how I do it here and then see them redone on your assignment. So I've got a pilot that's decreasing the landing speed from 70 meters per second to 10 meters per second in 30 seconds. What's the acceleration of the plane? Well, what are they giving me? They're giving me a time. They're saying that the time is 30 seconds. And they're saying that my change in velocity is actually a negative 60 meters per second. I've lost 60 meters per second here. It's a deceleration. I'm slower at the end than I was at the start. My unknown is the acceleration. I don't know what that is. But I do know, I go to my toolbox of equations that I just wrote, or I can look at that triangle. I know that my acceleration is my change in velocity divided by time. As I'm doing these problems, guys, I'm noticing a lot of people aren't using this to help them out. You can't get a question wrong, guys, if you use this guess method. You cannot. You can't get it wrong. Please use it, okay? It will help you solve all these word problems. So now my acceleration is a negative 60 meters per second. That's my change in velocity divided by my time of 30 seconds. And so my acceleration for this problem is simply a negative 2 meters per second squared. That's how they call it, because basically you have a meter per second divided by a second. So my answer here is a negative 2 meters per second squared. And that problem is on your assignment, so you can review that. Let's say we've got a second problem. A roller coaster is going to pick up speed as it goes down the slope. It accelerates at 6 meters per second squared. It tells you, that is what they're giving you. It's a gift. They are telling you that the acceleration is 6 meters per second squared. What is its velocity? They don't know what it is. For whatever reason, the writers of this problem don't know what the change in velocity is. They don't know what that is. After 3 seconds, I've just identified a time. 3 seconds is a time. So how are we going to solve this? Well, if I'm looking for my velocity, I can either look at one of my 3 equations or go to my triangle. But velocity is simply going to be acceleration times time. I substitute in what I know. I know that my acceleration is 6.0 meters per second squared. I know that my time is 3.0 seconds. And so my final velocity here, 6 times 3, is going to be 18 meters per second. I have a second squared in the denominator here, a second in the numerator. My final velocity ends up being 18 meters per second. I'm not going to try to trick you on these guys. I'm going to try to choose some easy numbers. I'm more concerned that you have the concept down. So we first solve for acceleration, then we solve for velocity. Now let's solve one for time. So you've got a boat. The boat is going to accelerate downstream, okay, at a rate of 5.0 meters per second squared. They're giving us that. That's awfully nice. So you look at this word problem, identify what they're giving you. How much time? They don't know that. They don't know the time. Does it take to reach a speed of 70 meters per second? So my change in velocity equals 70 meters per second. I start at rest. I'm getting up to 70 meters per second. So what is my equation to solve for time? Well, time is going to be, when I look at my equations, my change in velocity divided by my acceleration. Okay, I can just go to my triangle and look at that. That's what that triangle would say. I've got acceleration, change in velocity, I've got time, I've got acceleration. So if I want my time here, I'm going to take velocity divided by acceleration. Okay, so time, my change in velocity is 70 meters per second. My acceleration is 5.0 meters per second squared. 70 divided by 5, it will take 14 seconds for that boat to reach that velocity of 70 meters per second, accelerating at 5.0 meters per second squared. Box that up, wrap it up, that is your answer. So, you are going to have several problems similar to this on the assignment. Please complete the assignment. Submit it to me by Google Classroom by tomorrow. I'll be available on the chat to help you out. So if you look at kind of what we have here, okay, this is your assignment. And you'll see that those 3 demonstration problems I did are right here on the first page, so you can review those and kind of look at those. And then this is the assignment that follows. Okay, notice I've tried to help you out by telling you kind of how to solve this. Okay, so spend the rest of your time today working on that, and I'll be around to help you out. Hope you guys enjoy your day today.